and that we would find reasonable, and as a way of thinking about markets with few imitators, not perfect competition, but innovation and imitation in the absence of legal monopoly power. Fine? Not a problem. That's fine. Okay? Point is that it's a very different story. All right, so what's the other story, the ideal perfect competition? It's very simple. It's very simple. Okay? So let me give you the industrial organization version of it, which is trivial, and then give you the general equilibrium version of it. The simple story, the partial equilibrium, the industry equilibrium stories along one industry, everything else given, and it's literally verbatim Marshall. So there is a demand function. For some good. Okay? There is an innovator that has the potential to enter this market and build up capacity. So the assumption obviously is that the innovation is embodied. Right? It has a minimum size, and as I enter, I spend F, okay, to build up the innovation, and I build up a certain capacity. So the initial capacity is the decision of the innovator. I build up plants to produce the new goods that have a certain capacity, right? And I have a production function, depends on capital and maybe labor. In the simplest version, I'm here. That's, I produce a full capacity and I'm the only one. Now, people have made a debate here, the discussion is, oh, but then you're temporarily a monopolist. That's actually not true. At best, I'm temporarily a monopolistic competitor. Right? The reasonable way of thinking is that my good is a substitute for some other good. It's an imperfect substitute as opposed to the perfect substitute. Or, if you want, it's a perfect substitute, and the difference is that I have lower cost. Makes no difference. Right? Here, I take the price as given because it's fixed by the demand when I produce a full capacity. If my good is a perfect substitute for a good that has already been produced, it has already a market price, and what I'm doing is producing my good at a lower cost, I still take their price as given, and I just consider my cost. So the thing that matters is where my costs are. All right? And what matters is the difference between the market price at entry and my marginal cost. Do you understand? You can write it either way. It doesn't really matter because it's irrelevant. The issue at debate is not if innovator in the first stage, when it has first mover advantage, has or does not have monopoly power. The issue is what's the dynamic of the innovation process. Does the innovator come in because in the following periods she can keep monopoly power in a form or another, or not? Do I need the assumption that the innovator can keep monopoly power in the following period and exclude others from imitating to explain its behavior, or not? I know it's a long phrase, okay? But that's the question, right? The question is, what kind of assumption do I need to make about dynamic behavior of innovator imitators in a new industry to explain the decision to innovate? That's the question. And as a positive theory, what is the set of assumptions that better describes what I observe? So, sure, when I can come in, I can be an absolute monopolist. Almost impossible, but we can pretend. I literally invent a good that nobody ever thought of, and I satisfy for the first time in history a characteristic that has never been satisfied. No idea. Fine. For one period, I'm a monopolist, so I'm going to choose this a la monopolist, to maximize profit. I'm a competitive monopolist. There is some degree of substitutability between my good and goods already existing. Right? I'm the first smartphone, the first cell phone. Right? I'm neither a perfect monopolist nor a perfect competitor. My good is a partial substitute to existing goods. Sure. First period price will be determined by an existing demand with existing suppliers and me, computing my price. I can be a perfect substitute to existing goods. It's just that I'm cheaper than them. And so I come in with my new good is different, not in characteristic, but in cost and production function. I produce it with a different technique. I'm Uber, okay? And you're a taxi, all right? So we're perfect substitute, yes, but I have a cost structure that is different. So I take the price of the taxi as given and just price a little bit below that. Doesn't really matter, because the only thing that matters is at the capacity you come in the first period, are you making profits? And if you are, they're called competitive rents. Not only, they are the incentive to be imitated. Right? Imitation is costly. You have to invest and build capacity. So people will do it if and only if they expect rents. And so in next period, K0 is augmented and becomes K1. I may be adding some, other player may be adding some, we are on equal footing. That's the point. If there is no legal exclusion, if imitation is allowed, they will pay their cost, like here, and imitate. The point is that this will make capacity grow, and price will decrease. As long as there are still rents, the process will continue. Until when? Well, until, exactly as Marshall predicted, you reach a long-run position at which the rents are exactly equal to F, call it tilde, which is the cost of imitation and building that extra additional capacity. Right? You see that there is no difference, and in fact, one thing I found fascinating in the last 10 years is the undergraduate student at the university where I moved are actually very dedicated. So I teach a class for undergrad, senior undergrad, on innovation, intellectual property. And one thing I found very interesting is to assign students research project during typically 40 students, there's about 8-9 groups on innovative industries of the last century. And most of them work on obviously very new stuff, they're curious, right? And you see how many, and the challenge is always find examples and study industries and innovation that contradicts this story and actually resemble the one in which without monopoly, legal monopoly, blah, blah, blah. And there's never one. And so many stories are like this in the data. The one this year that was most beautiful was the tablet. But there is the one, for example, for live event on the internet, very similar, right? And a bunch of other, and the way, the current industry and the innovation process for electric cars on one hand and self-driving cars on the other are operating. In which you see the entrance and then you see the capacity build up and you see the imitators coming in and spending resources and prices going down. And you can also see, that's the dot-com case in 2000, that this process, nobody's perfect. So this is a process in which, obviously, when I draw the blackboard, or the whiteboard, or the dirty board, they have perfect foresight. They see exactly where the marginal cost is. They see, but that's the class. In reality, people just come in. And sometimes they come in too quickly. And they invest too much, and there is overcapacity. That is, in reality, sometimes people end up here. Right? And on here, you sell at a price that is below marginal cost. So you have a shakeout, right? You have .com 2000. Too many companies coming in, producing the same good, a lot of capacity, not enough demand, products too costly, lots of companies have to shut down, right? That's perfectly possible in this environment. Right? The model doesn't say you go here at the long run equilibrium automatically. You may go there and go back and forth. Okay? But that's the very simple story. Okay? So if you take the paper that we have on Journal of Monetary Economics, the first part of the paper is about this, just describing this before. It's very simple. But you see that the deviation from the assumption here are crucial, right? So it's crucial not to have unbounded capacity at time zero. And it's crucial to have the technology embodied in the capital goods so that you don't come in instantaneous, you have to build up. And this building up over time is what allows people to capitalize on the rents and make the profits necessary. Now one can say, well, you know, that's a technical, that's a empirical detail. Yeah, maybe it's an empirical detail, but it has the fantastic characteristics that it allows me to understand the process of innovation in real world as a mechanism driven by competitive behavior. Right? If I abstract from that, I end up in the world here. Instantaneous imitation, instantaneous fixed capacity, instantaneous pricing at marginal cost, and complete absurdity. That either only the monopolies stay in or nobody goes in. Okay? So now let's try to see how we do this in general equilibrium. To do it in general equilibrium, the thing to do is the following, is purely to note that you remember the way I told you, in the classic model of general equilibrium, we model production. Right? We model production with an activity. Okay? So in order to fix idea, we can start thinking that at the beginning of time, we just have one activity. Okay? There is one way of doing things. We have to produce wheat, and we produce wheat with a certain machinery, a certain way of seeding the ground. Okay? I don't know, some cows, whatever. Right? So we have a stock of capital of this type, call it type 1, at time t. And from that, we produce output at time t plus 1. Right? Now, when you do that, and you start thinking of technology being embodied, you have immediately to decide, that's, if you want to understand why I'm so obsessively against the one sector model, it's because I cannot even try to describe innovation in the one sector model. The reason why people have ended up using TFP, disembodied TFP, to model technological progress, it's because in macro, the desire to use the one sector model forces you to treat technology as disembodied. Right? How do we do this? This is a machine that produces some stuff that I can eat. Right? Now, if it is only one sector, one good, I'm stuck. I cannot do technological progress, you understand? right? Because I can pretend, so for example, one story I can tell is, this is literally rice. So there is the rice, the capital is the rice I put in the ground, and then Y is all the rice that comes out. Then I split it, some I eat, some I put in the ground, but it's always the same rice, right? So say I want to model the innovation by saying, okay, there is rice, I have a certain variety of rice, and I'm going to do two things. I'm going to put rice in the ground to grow rice and eat it, but I'm also going to a greenhouse, a little piece of the land, and try to extract from the rice the one with a certain characteristic, so I produce, over time a mutation, and I try to get a better type of rice, more resistant, say, to parasite, or with a bigger with more output per plant. I need to have two goods. If I have two goods, I need to have at least two sectors. See what I mean? If I want to embody my innovation in the new rice, in the new variety, and I want that variety to be different from the previous one, I have to treat it differently. It has to have a new label. Otherwise, I say I have technological progress and it's disembodied. You see what I mean? So think at all the technological progress that has happened in fact over centuries, and the fundamental one has been agriculture. It's been mostly through adaptation of plants varieties and also animals to different ecological environment. Different land, different temperature, different climate, different soil, blah, blah, blah. Different seasonal precipitation and so on, right? The big difference between the agriculture of East Asia and also India and here, but mostly East Asia, is purely the difference in precipitation. Wheat and barley and the plants we grow here are adapted to the the type of precipitation we have, the sunny periods and so on. The rice is adapted to the monsoon and the fact that precipitation comes very late in the hot season and it's in large quantity, blah, 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 right? So this is a technological adaptation. I have to go from one to another. So I need at least one or two or three sectors, depending, okay? So let me try to do that. Okay, so let me start again and say, okay, I have a machine of type 0. That's the first one. And I put the index there. And to make things simple, I'm going to start at type 0. And let's try to make it super simple. I take away labor. I'm going to put labor in a moment, but for the moment I'm just going to make the model so simple that everything is automatic. Okay? With that machine, I produce output a period later. All right? So in general, I go to the machine 0 time t into output at time t plus 1. What's the relationship between output and the machine? Let's make it linear. Right? So this is actually equal to beta times that. Okay? Beta is a positive number. Now notice that one thing I can do here is to treat this as an AK model. And again, there is no technological progress. I always stay with technology 0. Beta is a very big number. I accumulate, right? So, but I don't want to do that because I want to study technological progress. I want to be able to go in some form from K0 to K1, where 1 is different from 0 because it's more productive. Okay? All right? Well, to do that, I need two things, right? I need to have a way of innovating. So I have to use some of the goods I already have to produce the new goods. Now, in reality, what is that we do? Well, it depends, right? For plants, we use the plants we have and labor to produce the new plants. For animals, the same. For machines, more or less the same. We use some machinery we have and labor to produce new machines. In the pure general sense, we use labor and the human capital we have, the knowledge we have, to produce new knowledge. To the extent that knowledge is embodied, it's no different from this. We're always using some stuff we have, which is a stock, not a flow. Your brain, your knowledge, your books, your lab, your chemical products, your factory, your tractor, your cow, your horse, whatever, and plus you, with a certain type of you, to produce new things. So that's an activity. So in general, we can always discover this. That's a very strange thing that people haven't thought. The process of discovery, of creation of new good, is not different from the process of creation of all goods, right? It may be uncertain, it may be, I don't know, but it's the same thing.